are the functions differentiable at the indicated x value? So the first function we have f of x equals to x plus absolute value of x squared plus 2. Is this function differentiable at x equals to 0? I have a graph for you. So at x equals to 0, you have to, because this one clearly there is no vertical tangent and no discontinuity, and you have to use the limit to show that when x is equals to 0, you have a sharp corner point or not. So for checking sharp corner points, I will use the left limit and the right limit. So starting with left limit, especially for the absolute value of x. So starting from the left limit, as h goes to 0 from the left, we have f of 0 plus h. The 0 comes from the x equals to 0. If the question is asking is the function differentiable at x equals to 6, then you have 6 plus h minus f of 6, right? Okay, parentheses 0 plus h, and then plus absolute value 0 plus h, and then close the absolute value, close the parentheses, square plus 2, and then minus f of 0, and then you minus f of 0. So f of 0 is 0 plus 0, right? Square plus 2, and then you are subtracting the whole thing. I will be using a square bracket. And then you have everything divided by what? You have everything divided by 2, right? No. Divided by h. Alright, so let's clean this up. We have limit as h goes to 0 from the left. You have h, right? That one, this is an h, and then the 0 plus h, so that will be an h. Then you have h plus h, and then you have a h. Hold on. So this will be h plus absolute value of h, and then square plus 2 minus 2 plus 2 minus 2. So the 2's are gone, divided by h, and then you have limit as h goes to 0. You have to open up the factor. So that is h squared, and then plus 2h absolute value of h, and then plus absolute value of h squared divided by h. And then what do we have? You have to make a note here. So the absolute value of h, once you square that is just an h squared, because it doesn't matter what value you pick for h. After you square everything, the answer is always positive. So this one, you are actually having a limit as h goes to 0. You have this one you have a 2h squared, right? So 2h squared plus 2h absolute value of h divided by h, and then once you factor out an h, you have limit h goes to 0. You have a 2h plus absolute value of h, but once you plug in h goes to 0, you just have a 0. Because this one you have all the h. Once you plug in 0, everything is just equals to 0. So even though you let h goes to 0 from the right, the 2h plus absolute value of h is also equals to 0. So this is equals to 0, this is equals to 0. This is the left limit, this is the right limit, and they are equal. What does that mean? That means the function is differentiable at x equals to 0. So that's for the first one. And then the next one is more complicated. So the next one, look all the way to the top. We have a x times sine of 1 over x plus 0.5x when x not equals to 0. And this piecewise function equals to 0 when x is equals to 0. And we will need this information. Okay. That one I will just let h goes to 0 from either side. So this one I will just do a limit as h goes to 0 from either side. F of 0 plus h, I choose 0 plus h because I am studying x equals to 0. and then minus x f of 0 divided by h, and then you have limit as h goes to 0. 0 plus h, so you have a 0 plus h, and then sine 1 over 0 plus h, and then plus 0 0.5, 0 plus h. So that's the first piece. And then the second piece, once x equals to 0, so this is this piece over here, once x equals to 0, the whole thing is just equals to 0. So you are subtracting a 0. And then you divide everything by h. Now, you might ask me, hey, you have a 1 divided by x. You plug in x equals to 0. Hey, how do you have a 1 over sine of 1 over 0 equals to 0? That doesn't make any sense. But take a look. That's why I said you will need this piece. When x is equals to 0, the entire function is just equals to 0. And that's why we specify this. Okay. Alright, the next step is you will have to fully open up the top. So when h goes to 0, before we dive into the detail, take a look at the first graph. So this one, as x goes from 0 from either side, you look at the center, there is nothing you can say. You can't really tell anything when x goes to 0. So the conclusion is, for this type of problem, if you just look at the graph, it is very hard to tell what is going on. Again, when you just look at the graph, it is difficult to tell what the answer is. You have to go through the detail to find out, is that a corner or not a corner. All right, we have h, and then sine 1 over h, and then plus 0 0.5 h, and then divided by h. The factor is easy. So if you just factor one h out, this is gone, this is gone, this is gone. And then you will just let h goes to 0. So once h goes to 0, so this one, once h goes to 0, you have limit. You can break this down into two limits. Sine of 1 divided by h, and then you add. It's a plus, right? Yep, it's a plus. And then limit h goes to 0, and then you have a 0 0.5. Is this limit exist? The answer is no. So this limit is between -1 and 1. If you look at this picture, sine 1 over x is bouncing or oscillating between -1 and 1. So this is between -1 and 1. So this limit does not exist, and this limit is equals to 0 0.5. So overall, we say that the entire limit does not exist. So that means the function is not differentiable. So it's not differentiable at x equals to 0. So that's the answer to the second piecewise function. And then the next piecewise function, we have that in blue. I already copied that for you. So we have the third piecewise function, and then here is the graph. As always, if you just look at x equals to 0, right in the center, there is nothing you can say. You can't really tell anything. Okay, let's work into the details. So that one, I will use the same method. I will take a limit. So the question is still asking, is the function differentiable at x equals to 0? That's what I'm trying to ask. Okay, and then we take limit as h goes to 0, and then we have f of 0 plus h. Again, 0 comes from here, minus f of 0. Got that? Yes, minus f of 0. And then divided by h. Divided by h, and then you do the plug-in. So you have limit as h goes to 0. You have a 0 plus h, then you have a 0 plus h squared times cosine 1 divided by 0 plus h, and then minus 0, this is equals to 0. This 0 comes from here. Because when x is equals to 0, the function is equals to 0. I bring the 0 over here, and then I bring this piece over here. And then you have everything divided by h. And then once you open this up, I'm going to save a little bit of space. I will just keep writing the limit. So you have a h squared, and then cosine 1 over h, and then divided by h, and then you will get rid of this square and the h, and then now you are safe to plug in 0. So once you plug in the 0, do we agree that we have an h, and then times cosine 1 over h. So cosine 1 over h is between 1 and negative 1, but this is equals to 0. This is equals to 0. And then this is between 1 and negative 1. So overall, we will just say that this is equals to 0. So that means the function is differentiable. So is differentiable at x equals to 0. All right, so that's it for this video. If you like it, give me a like, and I will see you all in the next one. Signing out.